This is 6.1, rational exponents and properties of exponents. There's a lot of properties going on here with exponents. This is a two-part video, and I'm only going to be able to cover the first part of it in this first video. And there's a lot of rules to exponents, and you have seen them before in like a previous class. And so I'm going to go quickly through each one of these rules, and you just really need to practice these rules to make sure you know the difference between each rule and when to apply them. All right, the very first rule is, it's called a product rule. Remember, the word product means to multiply. So the rule says when multiplying like bases, you add the exponents. So just as a refresher, the base is this down here, whatever the base is, and then this is the exponent or the power. So when the rule says when multiplying like bases, so you have, like here I have the base of the x. The x's are the base. So when you're multiplying like bases, you add the exponents. And let me explain, I mean, the answer is x to the fifth. Okay, notice the base does not change. But let me explain why this rule actually takes place. So x squared literally means x times x. X cubed literally means x times x times x. And notice I have 5 x's. And so, 1, 1, 1, 1, and that's 5 of them. So the rule works, and that's the quick way to do it is just to simply add them. Like this next one, x to the 5th times x to the 9th. Notice the base is still x. All right, the base does not change. I don't want to write out 5 x's, 1, 2, 3, 4, 5, and then 9 x's. I don't want to keep doing this every problem. So the quick way to do this is to memorize that rule. When multiplying like bases, you simply just add the exponents. So I have the x to the 5th times x to the 9th is the same as x to the 14th. So let's move on to the next one and speed it up a little bit. So here I have the x's that are being multiplied together. Those are, again, the base doesn't change. And then when you're multiplying like bases, you add the exponents. Remember, this is a 1, so you're going to add those together. That's x to the 3rd power. And the same thing with the y's. When multiplying like bases, you add those exponents. So the final answer is x to the 3rd, y to the 8th. Let's go to the next one. Notice when you're multiplying like bases, again, the base does not change. So when you're multiplying like bases, you add those exponents. It's to the 14th power. But again, this is just, the numbers are just 2 times 8, that's 16. Again, that rule is just 2 numbers being multiplied together. So that's why you're not really using the product rule directly on that. All right, so let's go to the next one. So I have the base of a 3, and so the base does not change. I keep saying it, the base does not change. So the base is 3, and then notice I have 4 of them. I have 6 of them. That means I have 10 of them. Now let me just point out a common mistake with this. Students will see 3 times 3 and they'll write 9 to the 10th power. Well, again, the base doesn't change, but if you actually take 9 to the 10th, that literally means 9 times 9 times 9, 10 times. And that's really not what's taking place. This is 3 times 3 times 3 times 3, and this is 3 times 3 times 3 times 3 times 3 times 3. And so there's 10 of the 3's, not 10 of the 9's. So again, don't actually change the base. All right, let's go to the next one. Notice the base is -8. The base is -8. The base is -8. So the base is not going to change. You're just going to simply add the exponents. And you better get to the final answer. The base does not change. All right. Let's go to the next rule. The next rule is the power rule. The power rule is when you have a power raised to another power, you multiply the powers. So here, again, just do the exact same thing as what I said. The base does not change. It's just when you have a power raised to a power, you multiply the powers. That's it. And let me explain why it actually takes place. So you have the base, x cubed, but it's being repeated 4 times. It's being repeated 4 times. And then that literally is 3 and 3 and 3 and 3. That's 12 of them. And you can actually write this out if you wanted to. See, that's 3 of them, that's 3 of them, that's 3 of them, and that's 3 of them, So you can literally write it all out if you wanted to, but you can see that the fast way is just when you have a power raised to a power, you multiply the powers. So here again, the base doesn't change, and then you just simply multiply the powers. Now this, again, you have the base of a W. Now inside the bracket, you have a power raised to a power, so you multiply the powers. Now the rule applies again. You have a power raised to a power, the base doesn't change, and then you just multiply the powers. That's the power rule. The product of powers rule. Now this one takes a little bit of explaining. If you're multiplying different bases. So let me explain that. So look down at my first example. So if you're multiplying like bases, not adding. So this does not apply if I have this. Okay, this does not apply. So only if you're multiplying inside those parentheses, not adding. So if you're multiplying different bases, and that's raised to a power, then multiplying powers to each power of each base. Now that, again, that sounds kind of confusing, but look what that really is talking about. What you're going to do, if you're multiplying, then you're going to do the power rule to each item inside of there. The base doesn't change. So you're literally going to just multiply those powers to each of them. Again, only if you're multiplying inside, not adding, not subtracting, only if you're multiplying inside. So again, am I multiplying inside? Yes, I am. So each of the bases, I have a base of a 3, I have a base of a W, I have a base of an X. And then you're going to multiply the powers to each of them. And the only thing I would suggest on this one, 3 cubed, we would probably need to simplify that to 27. So this would be the final best answer to be able to do that. Again, the base does not change. Look at all the bases. I have a base of a 2, I have a base of an A base of a B, and a base of a C. And everything has an exponent, so you just multiply each of those. That's to the 5th power, 10th, 15th, 20th. And again, the only thing I would suggest is simplifying 2 to the 5th, which is 32. And that's the product of powers rule. The quotient rule. The word quotient means division. So when you're dividing like bases, you subtract the exponents. So here I'm dividing like bases. Notice the base, they're the same base, and the base doesn't change. And so you simply subtract the exponents. So you take the top minus the bottom. So the answer is x squared. And again, the reason why this works, x to the 4th over x to the 2nd. And these literally will cross out, like 2 of these, like this x crosses out with that, this x simplifies with that, and you have 2 x's left over on top of the fraction. So that's why it works out. So again, you can always, if you get confused on these rules, you can always write it out. Like I don't want to write out x to the 13th. I don't want to write out, x, 13 of them, and then on the bottom write out x, 8 of them. I don't want to do that. So it's easier to memorize a quick rule. The base doesn't change. You have 13 of them up top, 8 of them on the bottom. That means I'm going to have 5 remaining up top. Okay, so that you can write over 1 if you want. So let's look at the next one. The base is 7. Okay, the base doesn't change. And then you have 13 of them up top, 2 of them on the bottom. That means I'm going to have 11 of them remaining up top. So let's look at the next one. The base doesn't change. The base is 9. Again, don't actually take 9 divided by 9 as 1. Don't do that. The base doesn't change. And I have 21 9s up top, and I only have 15 on the bottom. That means I'm going to have 6 remaining up top. Now, let me emphasize this too. If it was on the bottom, like if I had that same problem, if I had 9 to the 15th up top and 9 to the 21st on the bottom, well, notice I still subtract the exponents, but notice the majority of the exponents are on the bottom, so I would actually have 1 over 9 to the 6th. All right, the majority of them are on the bottom on that problem, so you have to look where they're located. All right, so let's look at this next one. Again, the base doesn't change. Notice I have the x's right here. The majority of them are down at the bottom, and how many more is I have 6 more of them on the bottom, so x to the 6th on the bottom. Look at the y's. I'm going to subtract the exponents, but look where the majority of them, the big number, is at the top. So that means I'm going to subtract the exponents, and it's going to be y to the 8th up top. So on a problem like this, you have your m's. I have 2 more m's up top, so it's m squared. I have 3 more w's up top, so that's going to be w cubed up top. But I have I have 4 more z's on the bottom. So that would be the final answer on that one. Again, I'm just basically subtracting the exponents, and you just have to notice where the majority of them are, whether at the top of the fraction or at the bottom of the fraction. All right, another rule is the 0 exponent. Anything raised to the 0 power is 1. It's that simple. I mean, you just have to know that rule. So x to the 0 power, that literally is 1. M to the 0 power is 1. 5 to the 0 power is 1. And then I have a bunch of stuff inside parentheses, but notice the parentheses is being raised to the 0 power, so the answer is 1. Anything being raised to the 0 power is 1. And then finally, negative exponents. Negative exponents, there's a couple things you need to know with that negative exponents. You can't leave your answer with a negative exponent, unless the directions specifically tell you to do that, but they rarely ever tell you to do that. So you never leave your answer as a negative exponent. So what do you do with them? Well, a negative exponent represents the reciprocal. So you basically take the reciprocal of that base. So here, this is x to the 8th power, but notice it's a negative exponent, so this literally is going to be flipped. You take the reciprocal of it, so it's literally 1 over x to the 8th. So this right here, it's m to the 4th. Notice the negative exponent means to flip it, so I'm going to flip m to the 4th to the bottom. So this, again, I have a negative exponent, it means I'm going to flip 7 to the 13th power up top. So here you have x to the negative 12th, but notice it's negative, so I'm going to literally flip that to the bottom, and w to the negative 14th, but I'm going to flip that to the top. So again, leave your answer as positive exponents to be able to do that. So even if I have something like 2 to the negative 3rd power, well, 2 to the 3rd power is 8, but notice it has a negative exponent, so it's 1 over 8. So that's the negative exponent means to flip the fraction. You flip the fraction. So whatever that is, you just flip that. And that's what negative exponents are. And that is part 1 of 6.1. 6.1 talks about exponent rules, and it also talks about rational exponents. So we're going to go into video 2. Make sure you watch that to be able to make sure you understand all the rules with exponents.